my name is Pak Pati Berdua, my team number 822 I will present a data preparation. Okay, data is information or made with word citation, symbol, and numbers, etc. This data held in the time and process and assign basic multiple result. Primary data, type of data. Primary data. The data is information column that learning as on time for interacting help with the subject interact received by entity or individual. Secondary data is information to edit based on time from the sound that is before. So that one does limit or time information deadline to a data set subject and to a secondary data. Visual data or data. They belong or they get is the category variant. They value allow us to upload and they focusing independent as a power dedicated to have brown work by focusing on the very basically blind and category on its test. In the version 3 order kit, you numerical value one of is scalar greater than 100 and all every as a single per 100 kilometer. First in consuming per 100 kilometer in my topic is greater to 100 with offer a very impressive positive or not part accepted by the cat. The following numerical value is can this station the level per liter on capital L to calculator how far in level a single liter phone also power and all total also power just and evening so independent numerical balance the average engine and power aspect to especially accessory by unlocking this variable with inflation line so audit version and generally also power and phone cost position.
Hi sir, my name is Turkadili Samsundra, my ID 822800046. Today I am here to present 2.0 sampling data and record categorical data. Here is statistic data. So we had selected 150 observations randomly from 392 observations using data set A that has been provided. Then we had recorded all the numerical data as mentioned above on data description. It is easiest for us in calculate the frequencies. 3.0 numerical descriptive measures. For here, I would like to explain liter per 100 measure of central tendency, which is mean, mode, and median. Firstly, I would like to explain mean. So the equation is x equals to 953.96 equals to 150 equals to 6.36. So 6.36 is the mean of LP100. However, for median is 75th observation, therefore the median class is 5.28 minus with 6.28. The equation is 4.78 plus with 150 divided by 2 minus 32 over 47 and times with 2. So the equal is 6.61. About 50% of LP100 is 6.61. The equation for mode is 21 divided to 21 plus 10 times to 2 and plus with 4.78 equals to 6.30. The highest of liter per 100 is 6.30. Measure of position plus interval is 6.29 minus it's 7.29. For find value quartile 1, 4.78 plus with 37.5 minus with 32 over 47 times with 2. Quartile 1 equals to 5.01. For find value quartile 3, 112.5 minus with 79 divided with 37 times 2 and plus with 5.79 and equals to 7.6. In the quartile range, quartile 3 minus with quartile 1 equals to 7.6 minus 5.01 and equals to 2.59. So the last one is measure of variance. So the equation is for variance is s square equals to 1.92. Standard deviation is s equals to square 1.92 and equals to 1.39.
Hi, good day everyone. I'm Renita Shubhan, daughter of Vera Murugan, and my matrix number is 822A1196. So today I'm here to present central tendency, measure of position and variation of horsepower and weight. Okay, first the class width of horsepower is 0.20, which is the formula is maximum entry minus with minimum entry divide with number of classes. So the answer I get is 0.20. Next Next, I will explain how I get the mean for horsepower. So before that, the mean point is 12.04 and then the total frequency is 150. Okay, number 2, to calculate a median, we should know what is the lower class boundary of median class, frequency of the median class size or class width, and also cumulative frequency before median class. Therefore, the median class is 1.30 and 1.50. The class width is 2 minus width 0.8, you will get 1.2. About 50% of horsepower is 1.2. The third one is mode. So to calculate mode, you should know what is the lower class boundary of the model class, the difference between frequency of model class and the frequency of the class before model class, and also the difference between frequency of model class and the frequency of the class after model class, and also class size. The mode class for this horsepower is 1.30 and 1.50. So how I get the highest horsepower, which is 1.37, is 0.8 plus with 28 divide with 28 plus 30, and then you times with 1.2. You will get the highest horsepower, which is 1.37. Okay, compare with this mean, mode, median. Mean I got 1.37, mode also 1.37, and median is 1.2. So mean bigger than median, and median smaller than mode. So there is no clear shapes of data distribution. Next, I will proceed to explain measure of position, measure of number of horsepower. So I will explain here how I get the first quartile and then third quartile and also interquartile range. For the first quartile, I got 37.5 and the class interval is 0.88. And 1.08. For the third quartile is 102.5. The class interval is 1.57 and 1.51 and 1.71. For the first quartile value, I got 1.52, which is 0.38 plus with 37.5 minus with 9 and divide with 30 and lastly times with 1.2. For the third quartile, I got 1.4, which is 1.01 plus with 102.5 minus with 107 divide with 17 and then lastly times with 1.2, so I will get 1.4. Next interquartile range is quartile 3, the third quartile, Q3 minus with Q1, which is 1.4 minus with 1.52. I got negative 0.12. Okay, the last percentage tendency for horsepower is, I will explain how I get variation, measure of variation, variance, and standard variance. Standard deviation. So variance I got 0.13, and for standard deviation I got 0.36. Okay, next I will present measure of central tendency, measure of position, and variation of weight. So the class width of weight is 0.250. And okay, the answer for mean for weight is 3.90, median is 3.00, and mode is 2.66. So from here we can see that mean is bigger than median, and then median is bigger than mode. So the shapes of data distribution is the shapes go to the right. Next, measure of position. For the first quartile, I got 37.5. The class interval is 3.139 and 3.389. So for the third quartile, I got 112.5. The class interval is 4.143 and 4.393. The value for quartile 1, I got 4.20, which is 2.639 plus with 37.5 minus with 0 divide with 30 and then times with 1.25. You will get answer 4.20. Value for quartile 3, the calculation is 3.643 plus with 112.5 minus with 22 and then divide with 124 times with 1.25. I got 4.56. Next, the calculation for the interquartile range is quartile 3 minus with quartile 1, which is 4.56 minus with 4.20. I got 0.36. And then okay, next I will explain how the calculation for variance. So the calculation is 1 over 149 times with 2322.90 minus with 2281.50. So you got the answer 0.28. And for the standard deviation, I got 0.53.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aisyah binti Baharun. My matrix number is A22B0022. I will continue with the graphical representation. To depict the liter per 100 horsepower and weight, we shall use an ORGIF or cumulative chart. From the ORGIF graph above, we can describe 8 class intervals. From the class interval, we can determine the midpoint for each of the class interval. The graph above shows 2 types of the axis, which is the x-axis with unit sales and y-axis with frequency. At the midpoint of 5.78, the graph started to increase and it reached the highest frequency at 47. Next, at the midpoint of 10.83, it started to drop to the frequency of 1 drastically. Next, for the horsepower, at the midpoint of 1.4 T, the graph started to increase and it reached the highest frequency at 48. At the midpoint of 2.24, it started to drop the frequency of 7 drastically. Next is weight. At the midpoint of 3.264, the graph started to increase and it reached the highest frequency at 30, but it started to drop to the frequency of 6 drastically when at the midpoint of 5.021. Next, to display the liter per 100, horsepower and weight, we also use a histogram. From the histogram above, we can describe 8 class interval, and from the class interval, we can determine the midpoint for each of the class interval. At the midpoint of 4.78, the graph started to increase and it reached the highest frequency at 47. Next, at the midpoint of 10.83, it started to drop to the frequency 1 drastically. Second is horsepower. At the midpoint of 1.40, the graph started to increase and it reached the highest frequency at 48. Then, at the midpoint of 2.24, it started to drop to the frequency 7 drastically. Lastly, for the weight, the midpoint of 3.264, the graph started to increase and it reached the highest frequency at 30, but it started to drop to the frequency of 6 drastically when the midpoint at 5.021. Lastly, we use pie chart. So this is the pie chart for brand of the car. Next, I will describe about numerical descriptive measure. Measure of the central tendency for liter per 100, we compare the result using SPSS software and manual calculating. For the mean, SPSS, we got 3.5503, while with manual calculation, we got 6.36. For median, we got 3.0000, and for manual, we got 6.61. For the mode, we got 3.00 for SPSS, and for manual, we got 6.13. Next, the horsepower. The mean for SPSS is 3.8800, while the manual is 1.37. The median is 4.0000, and the manual is 1.20. Mode for SPSS is 4.00, and manual is 1.37. Lastly, for the weight, mean for the weight for SPSS software is 3.5333 and manual is 3.90. Next, for the median, SPSS is 3.0000 and manual is 3.00. Lastly, mode is 1.00 for SPSS and manual is 2.66. The data of the mean median show the difference because of the SPSS cannot read the data accurately. All the data used above is already recorded. Next, measure of position. For liter per 100, quartile 1 for SPSS, we got 3.0000. For manual calculation, we got 5.01. For quartile 3, we got 4.0000 for SPSS, and manual calculation, we got 7.60. For interquartile range, for SPSS, we got 1.0000. For manual calculation, we got 2.59. Next, the horsepower. The quartile 1 for SPSS is 2.0000. For manual calculation, we got 1.52. For the quartile 3, we got 5.0000 for SPSS, and manual calculation, we got 1.4. Lastly, interquartile range, for SPSS, we got 3.0000, and manual calculation, we got 0.12. Next, the weight. Quartile 1 for SPSS, we got 2.0000. For manual calculation, we got 4.20. For quartile 3, we got 5.0000, and for the manual, we got 4.56. For the interquartile range, we got 3.0000 for SPSS and 0.36 for manual calculation. Standard deviation and variance show different results because the error of system SPSS to analyze the data separately, which is the data class interval is too large. All the data used above is already recorded. Lastly, the measure of variation. For liter per 100, sample variance for SPSS, we got 1.817. For manual, we got 1.92. For standard deviation, SPSS, we got 1.34785. And for manual, we got 1.39. For horsepower, sample variance for SPSS, we got 3.046. For manual calculation, we got 0.13. For the standard deviation, 1.7455 we got for SPSS, and for manual calculation, we got 0.36. Lastly, for the weight, sample variance for SPSS is 4.036. For manual, we got 0.25. Standard deviation for SPSS is 2.00893. For manual, we got 0.53. The result SPSS for data sample variance and standard deviation is not the same as manual because the SPSS cannot read the data accurately. All the data used above is already recorded. That's all from me. Thank you.
Hello and hi, my name is Muhammad Mujahid Benghajari. My meeting number is 822800462. So I will present about 5.5 for irradiation modeling. So based on the scatter plot matrix on the right side, figure above show the association between liter per 100 horsepower and weight. There is a high level positive association between liter per 100 and horsepower and weight.
Proceeding to the hypothesis testing phase, the ANOVA table provides insight into the outcomes of the hypothesis test conducted on two variables, horsepower and weight. Within this framework, the null hypothesis asserts the absence of a significant difference between groups for both horsepower and weight, while the alternative hypothesis posits a notable difference between groups. Upon examining the p-values associated with horsepower and weight, both are found to be less than 0.01. This indicates that at the specific alpha level of 0.05, we have sufficient evidence to reject the null hypothesis for both variables. Consequently, the findings highlight statistically significant difference between groups for both horsepower and weight, underscoring the significance of the observed variation in these variables. Within the correlation analysis table formatted in SPSS, the examination of Pearson correlation coefficient sheds light on the dynamic relationship between two key variables, horsepower and weight. Employing a Pearson correlation test, the objective was to scrutinize the existence of any visible relationship between horsepower and weight. As shown by the comprehensive table, the result of the Pearson correlation underscore a statistically significant and positive association between horsepower and weight. The correlation found to be statistically significant at a level below 0.01 proved the presence of a robust positive relationship between the two variables. This compelling evidence not only supports the affirmation of a positive relationship, but also reveals the strength of this correlation, exemplified by the consistently high percentage of correlation of 0.730. The carefully examination of these correlation findings adds valuable insight into the intricate interplay between horsepower and weight, enriching our understanding of their interconnected dynamics.
Moving into regression linear for the scatter plot matrix. So for the first correlation, the value of R between liter per 100 and horsepower 0.855 and weight and horsepower is 0.865, in which show the strong positive correlation. For the model summary, according to the table of model summary, the R square value is 0.785, which means 78.5% of the variation in horsepower can be explained by liter per 100 and weight. According to the table of ANOVA, the p-value from the ANOVA table is 0.01, which is less than 0.05. Therefore, at least one of the two variables, which is liter per 100 and weight, can be used to model horsepower. For efficiency, dependent variable is horsepower. The equation horsepower equals 0.85 plus 0.96 liter per 100 plus 0.226 weight. Thus, for every unit increase in horsepower, liter per 100 will drop by 0.096 provided the other variables remain unchanged. Similarly, for every unit increase in weight, horsepower will go up by 0.226 units provided the other variables remain unchanged. The 90% confidence interval for the liter per 100 is 0.73 for lower bound and upper bound is 0.119, where the value of 0 falls within the interval, again indicating liter per 100 is not a significant predictor of horsepower, where the 90% confidence interval for the weight is 0.181 for lower bound and upper bound is 0.271, where the value of 0 does not fall within the interval, again indicating the weight is not a significant predictor of horsepower.
In conclusion, Assignment 2 pull in battery when control and the statistical computation are required based for this report. Use the data with calculator drive or lecture 130 sample with interval plus 100 as power, and when with it included in the dataset we use will recover the result obtained using the SPPS system and the manually computer value deeper the value with quantitatively the quantitatively various standard deviation, media, mode, and mean, and or the deeper methods use data argument, graphical methods, misuse and tendencies, misvariation with position.